So we're on exercise 5B, and we won't start 5C till next week, so you'll have all of today, you'll have Friday, and I'm going to talk to you not too much in that time. But can I just remind you a couple of things on here that we spoke about last lesson? On this globe, a great circle is a circle that goes the whole way around and forms what is essentially the biggest circumference we can. The equator is a great circle. Every line of longitude that goes from the North Pole through the South Pole and creates a circle in between is also a great circle. But we also have small circles. So a small circle, for example, would be the circle where you just cut the top off the globe. That would be a smaller one. So you can see here the diagram that represents that you've been working with, and you've already had a look at some of this in your work. We're looking at mostly distances on the globe, and so I'm probably going to just run those two things together with you today so you can do great circle distances. We've already done most of the calculations associated with that, and small circle distances. But you do need to make sure you know the language. So there is longitude and latitude, the equator, north and south pole, etc., using north, south, east and west in our angles, etc., etc. So there's some stuff in here for you to have a look at and keep on working on today. So we did that. We got down to here. So we also talked about this a bit, distance along the meridian, or a great circle distance. And we did this calculation, but what I didn't introduce to you was this number here, 111.2. It will be a really important number to remember, which I think, if I don't smash my computer, might actually be on your formula sheet, but it might not be as well. Oh, yeah, it is. There we go. Earth geometry, 111.2 times the angular distance. So this comes from the fact that we did this calculation the other day. The circumference of the Earth is 40,030 kilometres. There are 360 degrees in the Earth. So if you divide 360 into 40,030, each degree around the Earth, every time you travel 1 degree around the Earth, that's worth 111.2 kilometres. Now, doing the full circumference of the Earth is something that none of us will do exactly, and it doesn't really make sense to how we live and what we do, but this does. If you drive 111.2 kilometres in a straight line, you've gone 1 degree around the Earth. That's how that works. Okay? So that's that ratio, and this becomes really important because if I ask you, and this is a question that can easily pop up in an exam, if I say Sydney is on the line of longitude, I think it's about 157, and let's say a city on the west coast of Australia. Am I looking at Australia? No, there we go. On the west coast of Australia that's a similar height to Sydney, maybe Geraldton I think is. No, that's closer to Brisbane. Oh, Sydney and Perth is pretty close. So let's say Sydney and Perth. Let's say Perth is 137. Well, then the distance around the globe is 20 degrees. And you can use that and this idea to work out how far away they are. So it would be 20 degrees around the globe, 111.2 kilometres, 20 times 111.2 is the distance between the two. So that's all you need to do in terms of those calculations. The problem we have is if we have two cities that are here and they're on the same latitude but different longitudes, the distance is trivial. Just get that angle. If they're on the same longitude but different latitudes, again, that's on a great circle, that's trivial. The problem is, which is most cases, if they're like this, different longitude and different latitude. And to an extent, you won't have to do too much of that. You could work out a triangle, you could work out what the distance is on the horizontal, what the distance is on the vertical, and then you could use Pythagoras' theorem, but then because of the curvature of the Earth, it doesn't really work. So we've got a different problem there that you won't really have to deal with, okay? So any question that you get, you will find, and you'll have a look for this in your textbook, the two cities you're given will be on the same latitude or the same longitude, give or take maybe a degree, and then you just make an assumption based on that degree. So there's some information there. If you know the angle between the two, particularly if you're given the coordinates, longitude and latitude, multiply that difference by 111.2 and you've got your answer. And you can always use 111.2 and it's on your formula sheet. So that's always good. So here's an example. Beijing and Perth have the coordinates 40 degrees north and 116 degrees east. That's Beijing. Perth is 32 degrees south and 116 degrees east. and we're going to be asked to calculate the distance between them. These are on the same great circle, and you can see where they are. What is the angle between Beijing and Perth? Any takers? I'll give you two options. I'll make it a two-part multiple choice. Is the angle between Beijing and Perth 8 degrees or 72 degrees? Ooh. Maddie's gone 72. Does anyone want to disagree with her? Nobody wants to fight you, so that's good. Okay, it is 72. It could be 8 sometimes, but in this case, we're told that one of them is in the northern hemisphere and one's in the southern hemisphere. So Beijing is 40 degrees above the equator, north, so that's 40 degrees down to the equator, and then Perth is an additional 32 degrees below. So that's 72 in total. If they were both in the northern hemisphere, that difference would be 8. So you have to really make sure that you have a look at the north-south or the east-west, work out if they're in the same hemisphere or different hemispheres, and do the calculation from there. Okay? The good news is that what's going to happen in your exam is there's going to be time zone questions. And because there's time zone questions, you haven't done them yet, we will give you a map of the Earth with time zones on. So if you get a question like this, you don't need to know the time zones, but you will have a map of the Earth you can refer to and have a look at things. Okay? The difference on a flat map of the Earth between 8 degrees and 72 degrees is significant enough that you'll be able to work it out logically. So anyway, 72 degrees between Beijing and Perth. What is that as a distance? Anybody with a calculator want to do that for me? So, the angular distance, or angular difference, equals, Beijing is 40 degrees north, minus negative 32. The difference is minus, but 32 degrees south I'm going to write as a negative. That's 72 degrees, and therefore the distance is equal to 72 times what? 111.2, and anyone? 7,000. Oh, 8,006. Wow. 0.4 kilometres. And you know, you should all know the Earth reasonably well enough to be able to look at this and go, is that a reasonable distance? And I think 8,006 is pretty reasonable, so we're happy with that. And there's the answer anyway. Well, there's a map to show, a diagram to show the answer. Any questions on that? And that covers questions 7 to 11 in the exercise, but I might just talk about the distance on the equator as well. With the equator, we get exactly the same process, so there's not a great deal of depth we have to go into. Here's a diagram that's directly from your textbook. This is looking at the Earth from above. So that circle is the equator, and you can see the Greenwich meridian or prime meridian line here is 0 degrees. That's where England is. We're over here at about 157, most of the way around the Earth. And you can see the eastern hemisphere and the western hemisphere. If you visualise this, for those of you who were in math methods at this time last year, you'll be seeing a unit circle and hating it. But for the rest of you, if you visualise this, it will help you to really understand the angular distance and work with that. But it's all going to be from 0. So you're either going to have two places, one on the western hemisphere and one on the eastern hemisphere. You add the angles from 0, or they're going to be the same, in which case you find the difference. And so there's some information there that you can use. Here's a quick example of two places. The city's name, Pontianak. So you know that one? And in Indonesia, and Quito in Ecuador are on the equator to the nearest degree. The longitude of Pontianak is 109 degrees east, and the longitude of Quito is 78 degrees west. Find the distance between the two cities flying east from Pontianak. So you've got a map here, and you're told to fly east. You have to be careful of a question like that. If it says fly east, we're not talking about the shortest distance now. I'm about to knock my computer off, hold on. We're talking about the distance based on their specification. So here's there's North America there. So we're flying this way, east from Indonesia. It takes us over the international date line. So if Pontiac is 109 degrees, where is it here, east, then the distance from Pontiac to the Greenwich Meridian is 109 degrees. The distance from Quito to the Greenwich Meridian, which is here, is 78 degrees. If I add those two together, what do I get? 187 is the distance from those two in the opposite direction to what we want. So Indonesia's here. That distance around to there is 109. This distance around to here is 78. But we want to go east from Indonesia. So we're talking about going from there to there. So 189 degrees around the other way, what's left? $187 degrees the other way, sorry. 173. So we've got the angular distance, or the angular difference, is equal to 109 plus 78 degrees, but this is travelling west. And so that's 187 degrees if we travel west. That is that way and that way around the Earth. But we want to go the other way, so therefore the other direction is equal to 173 degrees, and the distance is equal to 173 times 111.2. I'm going to need some help with that as well. It should be about 19,000. Or not? 19,237 kilometres. Thank you. And that's our distance. Now, this is the shortest distance, so it makes sense. If you're not given some information, assume that the shortest distance is the way you're going to want to go. It's important here to note, though, if we're doing north to south, every line of longitude is a great circle. So that factor is 111 degrees. If we're doing east to west, the equator is the only great circle. All the other ones are small circles. Now, if I'm right up here at the Arctic Circle and I travel from somewhere in northern Canada around to somewhere in northern Russia, right up the top here, I'm going halfway around the world technically. They're on opposite sides of the globe, opposite hemispheres, but the distance is quite small compared to the distance around here. So later this lesson, or maybe on Friday, I'll talk to you about how we do that calculation. It's pretty simple, and I did mention it last lesson. But for now, great circle work is all you need to worry too much about. And that's question 12 to 15. And then that's pretty much it. And I think you could probably do question 16 to 19 as well if you read that example. So I'll probably leave it there for now. And we are halfway through the lesson. So